Well, welcome back as we continue our journey into introductory statistics, and in this series, Module 7, we are going to examine correlational analysis. And this first video constitutes an introduction to correlational analysis. I do want to point out that in life there are statistics, there really are three different issues. There's data, information, and knowledge. Anyone can generate data, but to convert that to information and obtain knowledge from it is what we're really about, and that's what our analysis really is about. Now, some observations that we want to make. Quantitative methodology to be utilized is driven by the problem. We don't choose a methodology and then design a problem. Rather, we come across a problem and we identify a methodology. Now, one of the things that you will experience as a researcher is that you will take a problem, you will identify a methodology, and in your mind that methodology will fit. Some other person will come along and point out all the things that you did wrong. Well, there is no one right methodology. And I'm very prone to say to people that want to come along and say, well, you should have done this. I'd say, well, that's excellent. Why don't you do it? You want to do your research, I'll do my research, and we'll both be happy. One of the great statisticians, George Box, he is truly a great statistician, but he said this. He said, all methods are wrong. Some are, however, useful. So, a person finds that they don't like the method you use, that's okay. They can use whatever they want to do their problem. You chose to use this, and yes, it may have weaknesses, but it's still useful. There's no one right way to do this. And the analysis is for the informed reader. I taught you in ANOVA that you had to follow protocols, and you showed that or demonstrated that the prerequisites were met, and if you had a prerequisite that wasn't met, you informed the reader. And then the reader could use the information and produce knowledge as they saw fit. Now, in this study, there's some terms that you need to know. The first of these is correlation. And correlation is a way of representing the relationship between two variables. In the t-test and ANOVA that we just completed, we were doing a comparative study. A comparative study is looking for differences between variables. And we're now beginning in the field of correlational analysis, and we will be looking not at differences, but we will be looking at relationships. And we will study these relationships two variables at a time. Correlation, a way of representing the relationship between two variables. Bivariate refers to two variables. Now, a bicycle has two variables. A unicycle has one tire. So when we talk about bicycle, we have two tires. Bivariate, we have two variables. And our correlational analysis is often referred to as bivariate correlational analysis. Bivariate means we're looking at two variables at a time. Correlation, we're looking for relationships, and we're analyzing for that relationships. Before you panic, now don't run screaming out of the room and have a nervous breakdown. This really isn't hard. Correlation is about relationship between two values, and you have relationships. There are close relationships, such as a sister or brother, and you might have a weak relationship, like between a fourth or a fifth cousin. Let's go back and look at that again. We have a close relationship, which could be entitled a strong relationship, like between a sister or a brother, and then we have a weak blood relationship, maybe between fourth or fifth cousins. Now, correlations are viewed as strong or weak. We have a strong blood relationship between siblings. We have a weak blood relationship between distant cousins. So a correlational analysis may be viewed as strong or weak. And you'll often hear us say, this is a strong correlation, this is a weak correlation. Or we may say this is a moderate, meaning that it's in the middle. Correlations are viewed as strong or weak. They're also viewed as positive or negative. Now, in order to understand this, let's look at developing the concept of positive and negative so that this makes some sense. Correlation is the relationship between two variables. You can be a friend or an enemy. And positive would be a friend, enemy would be a negative. In other words, friends go together, enemies go against each other. So let's move on. Correlations are viewed as positive or negative. Positive means that they're traveling together. As one goes up, the other one goes up. For example, the price of gasoline, okay? As supply goes, as inflation goes up, the price of gasoline goes up, all right? As bad weather blows in, the price of gasoline goes up. So those things could be said to be positive correlations. Now, negative correlations mean that they're traveling in opposite directions. As the supply of gas goes down, the price of gas goes up. So between supply and demand, we have a negative correlation. So we have identified that a bivariate correlation is a way of representing the relationship between two variables, and that the correlations may be strong or weak, and they may be positive or negative. Consider a couple of questions. Can you picture a strong negative bivariate correlation? Strong means that and negative means that as one goes up, the other one goes down. And strong means that they're very closely paired. As this one goes up, the other one goes down. Just right almost, a strong relationship exists. Can you picture a weak positive bivariate correlation? Positive means as one goes up, the other one goes up. Weak means, it kind of goes up. They don't exactly parallel right point for point, but they do go up together. Negative correlation means that as one goes up, the other one goes down. Positive means that as one goes up, the other one goes up. As one goes down, the other one goes down. They travel together in positive correlation. They travel against each other in negative correlation. Strong means that they're very much tied together. Weak means they're somewhat tied together. So picture in your mind a strong negative bivariate correlation. Picture in your mind a weak positive bivariate correlation. Look at what you have just obtained, a concept of a bivariate correlation that may be strong or weak, or that may be positive or negative. And as he says in the movie Mountain Men, Charlton Heston starred in that. The old trapper tells him, "You've done well to come so far with so much hair, with so many after it." One of my favorite movies. Now I tell you, don't panic. You've got this. You can do this. This isn't that hard. Positive means they travel together. Negative means they go opposite ways. Bivariate, it means there are two variables, which we compare them two at a time. Correlation means a relationship, and they may be positive or weak. It isn't that hard. Don't panic. You can do this.